Welcome to the first lecture in Software Engineering, Analysis and Design. In this course, we will be looking at the areas of software development. Before we can develop software or even build it, we must gather requirements, document those requirements, and validate them. And then, after validation, we will progress to software design. So the major objectives for this first lecture will be to describe the relationship among systems analysis, systems design, and software engineering. Then we will be describing the relationship between the software crisis and software engineering process. Because you recognize that software crisis evolved based on the fact that a large percentage of software projects, in fact 80% of software projects, are over budget. So by that measure, we could say that's a failure. And finally, we will look at some of the current business drivers that influences software development. Software engineering requirements, analysis and design. So the areas that we are looking at today are areas of software development, and the main objectives that we want to cover are the relationships among systems analysis, systems design, and software engineering. We want to describe the relationship between software crisis and software engineering process. We want to describe current business drivers that influence software development. So what is software engineering? Software engineering is the technological and managerial discipline concerned with systematic production and maintenance of software products that are developed and modified on time and within budget. So therefore what we're saying is that it's an engineering discipline. So it is organized, it's disciplined, so it is planned. So software products are large and they are complex. The development requires us to analyze and synthesize the problem. By analysis, we mean that we are decomposing, breaking down the large problem into smaller problems that are understandable. So if we have, for example, a large engine, we'll have to divide the engine into components and study each component to better understand them. So that's the work of the analyst. Then we have to synthesize. That is, we have to recompose them. We have to put them back together. So that's building the software from the smaller building blocks. So essentially then, the analysis process will move from the problem, the major problem that we have, and breaking the problem down into smaller sub-problems. Note, breaking the problem to smaller sub-problems, we may not get the same exact sub-problems depending on who perceived and how we perceive that problem. So then we take each piece of the problem and we develop solutions for them, and we attempt now to solve and to synthesize, to bring each piece back together. So that's the idea of synthesis. Synthesis is saying here that we are combining them and we are putting them back together. So we will be doing in the follow-on course the whole testing and validation of those pieces of artifacts that we have developed as we develop the solution, which we will call the system. So continuing on, this systems analysis then is the dissection of the system into component pieces so that we can study how those component pieces interact and work together. It can also be defined as the definition of business requirements and priorities for a new or improved system. So therefore, we may not have a complete set of requirements. So you may be asked to create a system that is allowing people to communicate in this COVID environment. and you don't know exactly what the problem environment is. So you're going to have to go out there. You're going to have to study what is happening. You're going to face a new paradigm, new types of issues that you may never have seen before. But because of the discipline that you would have developed in this course, you should be able to generate requirements and put them together in a formal manner so that we can test them, we can validate them, and then we can develop the design for them and move that towards implementation. Software design is a software engineering activity in which software requirements are analyzed in order to produce a description of the software's internal structure. So all along we were talking about the system. So the system, when we speak of it, we generally tend to talk about it from the driver perspective. But when we get to the design point of view, we are really the mechanic. Think of the mechanic. I don't want to say, if I was asked to go and employ somebody that really knows the work, I would go for a mechanic, because a mechanic can both fix the car and also can drive, because they know the details of the system, they know the components, how they work and how they function. So design for us is an engineering activity where we analyze in order to produce the description of the software's internal structure. Now, this description that is produced from the analysis is used as the basis for the implementation of the software development. So analysis and design is a subset of two distinct phases, any one of the process model. Hence, it is a subset of the software engineering process. So we cannot have a software engineering process without analysis and design. Communication. It is very important. Now, because we're going to work in teams, and if we work in teams, we must communicate. And that's how we develop common understanding of the problem that we're working on and are better able to come up with the best possible solution. So as we will discuss in subsequent lessons, communication plays a vital role in the software development process. And certainly the cartoon that is in your textbook, as well, we have borrowed this for the display as well. It shows exactly why communication is important. So it started off with the customer explaining what he or she wants. Then the next representation is what the project leader understood it to be. Then the analyst, based on what the project leader said, designed it. So you can see a difference there, right? Then we progress to how the programmer wrote it. Still different. Something is wrong. We're not communicating. Then we see how the business consultant described it. And all the way to the end, when we are seeing that all that the customer really wanted was just a tie and a piece of rope so that they could swing. Indeed, it is a laughable matter, but it is very serious. Communication is that common thread that runs through all the processes of software engineering. The software crisis, what really it is. Now, software engineering is a discipline that came out of the crisis of the 60s and the 70s. And, many of you were not born then. You would have just heard about those times. So and this was a time when many large software projects went over budget and deadlines in an unexpected manner. And that was a time when we didn't have a lot of the frameworks, the project management discipline that we have today. So therefore, it was like managing projects based on the seat of the pants. So software crisis is a term that is used by computer science to describe the difficulty of writing useful and efficient computer programs in the required time. So this was due to the rapid increase in computer power and the complexity of problems that could be tackled. But with the increase in complexity of software, many software problems arose because existing methods were neither sufficient nor up to the mark. So what we're saying then, software crisis arose out of you're giving a big tool to the software programmers to solve a problem, but that's not the only thing that is needed in order to get the best solution under budget, on time, efficient. We have to resolve that, and as a result of that, many of the tools that we will be using in this course were developed in response to the software crisis. Now, in 1968, it was a seminal year for the NATO conference that was held in Germany, where they looked at the solution to the software crisis. And here, 50 top computer scientists, programmers, and industry leaders got together to look for a solution to the difficulties in building a software system. And out of this came the term software engineering. Of course, engineering really is finding solutions to problems. So hence that definition came out of the NATO conference that says it is a systematic, disciplined, quantifiable approach to the production and maintenance of software. So nearly 3 decades later, in 1994, an article in the Scientific American by Wyatt Gibbs was titled Software's Chronic Crisis. So even 30 years later, we're still talking about the software crisis. And what is it? This was where large software systems, they often do not provide the desired functionality, they take too long to build, they cost too much, and they require too much resources. Resources in terms of time, money, and space. Now, software crisis cannot evolve. It cannot evolve to meet change. So these systems they are so big. So and they could not evolve to meet the changing needs. So they were just too specific, too close to the problem, and or to the technology. So as the technology changed, then you literally have to dismantle the software in order to come up with a workable solution. So for every 6 large software projects that became operational, 2 of them were cancelled. So on the average, software development projects overshot their schedule by half. Look at that. That's awful. And 3/4 of large systems do not provide required functionality. So if software development is such a crisis, what are we doing in this discipline? Well, where there are problems, opportunity abound, and that's why we are here. Now, these are not isolated incidents. So IBM did their surveys, and they surveyed 24 companies that were developing distributed systems. What did they find? They found 55% of the projects cost more than expected. 68% of them overran their schedule, and a whopping 88% had to be sustainably redesigned. Imagine that, doing rework. Imagine you're building your house, and after you have exhausted all the money you borrowed, you have to spend the money again to redesign and to remodel that house because that house is not functional. So can you imagine, you have done concrete walls and steel, and you realize the doors are in the wrong places, the bathrooms are not in the right place, and you need to reconstruct it so that it's functional. That's awful. Well, these are the parallels to the kind of problems that we encounter in software engineering, in software development, hence the software crisis. So what we are seeing here is that 18% of projects we said were cancelled, only 29% of projects actually were successful. That's not a good record. And that's why businesses are afraid when you go to them and say, I will build you a solution. They would rather go and buy something off the shelf. So the result of that was that business had to cut the purse string, and many projects were abandoned. In fact, based on what we are seeing here, more than 50% of projects were abandoned or cancelled because of overrun, and therefore, hence it was really a crisis. In 2002, surveys of information technology organizations found that 78% have been involved in disputes ending in litigation. So what we are saying is that, and so companies have taken developers to court because of this. So it is a crisis. So what's the weapon against software crisis? Well, we can improve software engineering. We can get rid of the crisis, or we can minimize the crisis by improving the software engineering methodologies. The high-level languages and tools that encourage and enforce these principles, we use those. So more and more high-level languages and tools have emerged that enables us to enforce the software engineering principles. The business drivers for today's information system. So today we're talking about information systems being the driver of literally everything. So whether you go to the ATM machine, whether you are using your cell phone, whether you're using the bus, you have to be aware of software engineering. You have to be aware of computing. You have to be literate today, because whether you want it or not, it's going to be forced upon you. So some of the drivers include globalization of the economy, electronic commerce and business, security and privacy. So imagine security in the past used to be this lone security guard that used to sit inside the bank. That was it. No, think of it. We used to just ignore that. We used to say it's a low-end job. But today, the same job is now performed by software, and it is expensive. Collaboration and partnership, because people have to collaborate. Knowledge asset management. So now people are seeing their systems as assets. So knowledge asset management have emerged as a new subdiscipline of systems, or of information systems. Continuous improvement and total quality management. So that has affected the entire gamut of business, and therefore it has affected the way we do our business of systems analysis, design, and implementation. Business process redesign. So those are some of the drivers. So let's now dive a little bit into these so we can get a better understanding. The globalization of the economy, what does that bring? It brings new and expanded international market, new international competitors. So no longer could we sit here in Jamaica and say, well, my market is Jamaica, and I don't need to be bothered by the competition that is overseas. No, what we see now, based on what is happening in globalization, we have seen that the whole world is our market, and therefore we have to step up. We have to have the skills. We have to have resources in order to compete. Next, the impact of information systems. It requires support of multiple languages, currency exchange rates, business and cultures. So information systems is no longer the domain of just a few people. It goes across various areas of the business. It cuts across cultures. It cuts across different kinds of economic systems. It requires consolidation of international data. So what we are saying now is that the data that we capture, because the same system that you build to operate in Jamaica is going to operate in China or in some Arabian country or in America. They use different currencies. They have different culture in terms of how they do things. And if the system is to be successful in all these environments, then the requirements has to be widely studied and validated across these varying environments. Demand for players who can communicate orally and in writing with management and users that speak different languages. So therefore, what we're saying with globalization now is that no longer can I just speak English or patois and then be comfortable with it, the way I communicate with my team members, but I may be working as part of a global team. I may be coding a part of the system, but the person who wrote the requirements may be living in New Zealand. There may be different time zones, etc. And I have to communicate with them. So therefore, how do I communicate? Maybe I won't. Do I have to be awake when they are awake, when we are really on different cycles? Or do we have standards that we have to observe in terms of how we document the system? And we all observe that. And so when they put the requirements, it's understandable. So the language must be common among all that uses the system. So therefore, the whole project management, the whole setup. So we need systems to manage systems. So systems to manage people. So even in the software engineering process, we're going to need systems to manage people, systems to manage the whole design process as well. So it is very complex and involved. E-commerce. So e-commerce is where we buy and sell goods and services by using the internet. So e-business, on the other hand, is not dealing with goods, but where we conduct support of day-to-day activities. So for example, e-business would now be those services that I would be doing in a banking environment, where I may be doing deposits, I may be querying my bank balances, I may be making withdrawals, I may be paying somebody. That's actually what we call the act of doing that, conducting that, the software that drives all of that, and the activity behind that is referred to as e-business. But the commerce tend to focus more on the goods side or the service side, the exchange of money using the internet, right? But the business side, just for clarity, the business side is actually the procedures that goes into making use of the internet to support what the business does. So there are types of e-commerce and e-business. So we have the marketing of corporate image products and services. So we have variants of them. Business to consumer. So that's where you're selling directly to consumer using the internet. Or business to business, where you are doing business with another business. And that's referred to as B2B. Now, what is the impact of information systems on e-commerce and business? Well, most new information systems are designed or are being designed to work on an internet or intranet infrastructure. So when you go into the organization now, they operate on the same browser that you use over the internet. But the difference is, well, you know the difference between internet and intranet. One is public and one is private. Now, since the only client-side software is a web browser, the choice of client operating system is becoming less important. So literally, because of the web, then I don't even know if the person that I'm conducting business with, are they on a Windows machine? Are they on a Mac machine or an Apple machine? Are they on a
a mainframe? Are they on a tablet? Are they using a phone? Are they using a watch? I could care less. Why? Because the browser, the web browser, and the web technology makes all of this possible. One common integrating system. So, so this is an example of an electronic commerce storefront. So Barnes and Noble sell their books, Amazon sell their books, and so many. You know about them. So we don't have to delve too much on that. Another one here is Ariba, where what Ariba does, they lit. What are they doing here? Here is a system where you are actually doing business, and in the way you do business, you hold your mouse over the button for detailed explanation. So if you were to hold the mouse over create, it would explain what creation is, status, approve, receive, explore, catalog. So it's much like a library system that is there. So what we are saying, the difference here between a storefront that is selling goods directly to you and another one that is selling knowledge to you, a training environment, much like a learning management system that has all kinds of interactive tools. Security and privacy. Security is how will the business continue in the event that we have a security breach or a terrorist attack or some kind of disaster. We have to deal with those issues, right? Right now, we have the COVID situation in Jamaica, and UTEC have had its direct impact. So how does UTEC respond to that and keep the systems going so that you can function and you can interact with it? How can the business protect its digital asset from outside threats? So that's a real serious concern, because the thieves are always lurking, and they will, for example, they will virtually take away your bank or remove a university and then hold your ransom to get back your data, right? Privacy. Consumers demand for privacy in e-commerce transaction. Government have requirements, so there has to be trade-offs. So what we know is that we need to incorporate stringent security and privacy controls in information systems. In terms of the other driver of collaboration and partnership, organizations seek to break down the walls that separate organizational department and functions. Organizations collaborate with outside business partners and even competitors. The impact for us, therefore, is that we need to provide secure external access. Because if we can't collaborate with our customers, with our partners that we are doing business with, that we are working with in a secure environment, then there are going to be leakages, and we are going to have no confidence, and the business will not survive. We need to pass data between different information systems. Knowledge asset management. Here we are saying that data, which we know as raw facts about people's place, events, and things that are important to an organization. Information, we say that, well, we kind of organize that into some meaningful way. So if I was to say, there's a boy, it's a boy. So I say he has a gender, and that gender is male. He has a name. Okay, he has a height. So when I have a collection of all of this, then I can now make some sense of the data. I have information. I can describe that person. So data that has been processed or reorganized into a more meaningful form for someone would be information. And going beyond that, knowledge, which is data and information that is further refined based on facts, truth, beliefs, judgment, experience, and expertise of the recipient. So what happened now? For us to get knowledge, we need to interrogate the information. We need to verify the information. So we do go through these things even when we are doing our requirements analysis and elicitation and analysis. So knowledge asset management recognizes that data, information, and knowledge, they are critical business resources. Hence, that's why we say that that knowledge is an asset. So how can the organization manage and share knowledge for a competitive advantage? Because we know that competitive advantage may be just temporary. It may not last forever. So we strive to integrate the data and information that can create and preserve knowledge. Quality management that emerged as one of the outcomes that has impacted software engineering. So we know about business processes, we know about continuous process improvement and total quality management. So what is a business process? So tasks that respond to business events. So example, if we do a sales order, or we generate an invoice, right? Or we issue a report. Those are processes that are involved. So business processes are the work, the procedures, the rules that are required to complete the business task, independent of any information technology that are used to automate or support them. Continuous process improvement. This is where we now continuously monitor those processes that we create. And why are we doing that? We're doing that because we want to see how we can, in a very small and incremental manner, not only small incremental manner, but they are measurable manner, improve the process and at the same time reduce costs and add value. Total quality management is another concept. It's a comprehensive approach to facilitating quality management, quality improvement, and management within the business. So this is a concept that is used widely. Its impact on businesses, its impact on IT and information system design is significant. Business process redesign. This is a study, the analysis and redesign of fundamental business processes to reduce costs and to improve value added to the business. It's very important. So more substantial changes emerge and improvements from CPI. So usually this is complemented by CPI. Right. So let's recap quickly. Let us recap quickly what we have discussed in this class. We have looked at the relationship between systems analysis, system design, and software engineering. And quite clearly, we have made a case where we see that in the beginning, when we attempted to develop software, it led to a crisis. It led to a crisis because there wasn't a defined, measurable, disciplined way. We lacked a number of the tools and procedures that we now have today. And that led to the crisis because of the lack of those resources. Happily though, lessons have been learned out of the 60s and 70s into the 80s and 90s, where many new tools have been tried. Some of them have been shelved. However, what has happened is that we have developed so many tools, which we will be exploring in the future lessons, to build systems, to analyze systems, to test systems. And so all of this would not be of any use if it was not for a specific purpose. And that specific purpose would be for the improvement of business. And that's why the discipline of information systems and computing is so important today, because it enables the business to collaborate and to work with us as we build systems that are aligned with those business objectives that will drive business to be more profitable, to simplify processes, to build new innovative software that not only will be done under budget but below cost, but ahead of time. So thank you so much. We look forward to the next lecture in this series.